Alright, so we're looking at integration using partial fractions. Now, to be honest, this isn't that tricky, this part, as long as you know how to do partial fractions. To be honest, whenever partial fractions comes up, usually it's like this, okay? There's never usually like a partial fractions question on its own. Usually it's an integrate this, and then you've got to use partial fractions, okay? So the first thing we need to really consider here is the fact that and this is this is something that people always miss, okay, always. What is that bottom? It's the difference of two squares, isn't it, yeah? So we need to, first of all, consider that there. So looking at the difference of two squares. So this is going to be the integral of 2 over x plus 1 and x minus 1 with respect to x. So then how do I write that? Using partial fractions? Yeah. So the first thing I'd do is I'd probably do it on the side actually. So x plus 1, x minus 1 is equal to a over x plus 1 plus b over x minus 1. We're then going to expand, we're going to make the denominator the same on that a and b side. So it's going to be, in fact, it probably not even worth putting that. It's probably equals a times by x minus 1 plus b times by x plus 1 all over x plus 1, x minus 1. Everybody all right with that and where that's come from so far? Just have a thumbs up, thumbs down, thumbs down. Good. So then we end up with this, don't we? Because the denominators are then going to cancel. So that there is going to cancel with that. And all we end up with is that 2 is equal to a times by x minus 1 plus b times by x plus 1. Like so. Now this one's quite easy, isn't it? Because all we need to do is let x be equal to 1 and x equal to minus 1. So let x be equal to 1. And in which case then we'd get 2 is equal to 0a plus 2b, is it? Yeah. So b is equal to 1. Okay. And then let x be equal to minus 1, in which case we end up with 2 is equal to minus 2a plus 0b. Yeah. So a is equal to negative 1. Yeah. Everybody all right with that? So then that leaves us with, let's just tidy that up. Okay, that leaves us with the integral of 2 over x squared minus 1 with respect to x is equal to a over x plus 1. Now, a is equal to minus 1, so that's going to be the integral of minus 1 over x plus 1 plus 1 over x minus 1 with respect to x. Everybody all right with that? And then how do I integrate that? It's gonna, if it's 1 over, it's going to be to the power of minus 1. Now, you've got to be careful. This one here is quite straightforward because it's just x. If it was 2x, then we need to differentiate and divide by that. Okay? But because it's x on its own, I know that I can literally write this like it's going to be ln of mod x plus 1 minus ln, sorry, plus ln of mod x minus 1, not forgetting what? Plus the c, yeah. Everybody right with that? And the last little stage, because you've got a minus ln, you can write this like this, can't you? So ln of mod x minus 1 all over x plus 1 using the laws of logs. There, like so. Everybody happy with that? Yeah. So let's just check those answers. There's those answers there. Brilliant. Everybody all right with those? So we've got another example here. I think we have actually got a test your understanding down here, but I think we should probably be able to do that one on the left. Do you want to have a little go at that one on the left yourself? And then I'll do the one on the right in a second, because I think that one's a little bit harder. We've just got to think about that repeated root, haven't we? We should know how to do that by now, but do you want me to start doing it and then I'll catch up? Yeah? Is everybody alright with me so far? Everyone got something similar, yeah? Yeah? Now be careful with that there. You can't just subtract them. You've got to use the laws of logs first. So you'd have to do the power law before you do the division law. And then that will leave you with, I'll tidy this up in a sec. ln of x plus 1 all squared all over x minus 2, close the brackets, plus c. Everybody alright with that? Yeah? Everybody alright with that one? So just thinking about this next one here, why is this one on the right a little bit trickier? Not that much trickier, but it is trickier. What's that, sorry? Yeah, it's the repeated root. How do I write a repeated root? How do I write the repeated root as a partial fraction? Yes, spot on. So it's going to be the integral of, I'll get you started on this one. There is going to be, you're going to have to compare coefficients on this one, aren't you? Usually that's what happens. So 2x plus 1 times by x minus 2 all squared is equal to a over 2x plus 1 plus b over x minus 2 plus c over x minus 2 all squared. Okay? So, if I simplify this now and I want the denominator, in fact I am going to do it actually. So it's going to be 8x squared minus 19x plus 1 is equal to, what do I need to times by? I need to times by a times by x minus 2 all squared plus b times by 2x plus 1 and x minus 2 plus c times by 2x plus 1. That makes sense? Okay. Then for this one, I still would probably pick 2 and a negative half first, just to kind of keep us with that one. So let x be equal to 2, in which case it's going to be so nasty. 8 times by 2 squared minus 19 times by 2 plus the 1 is equal to, well, that's going to be equal to 0a plus, because there's a minus 2, well, x minus 2, and that's going to be plus 0b plus c times by 2 times by 2 plus 1. If I substitute in on the left, what do I get if I do that on the left? What is 8 squared? What is 8 squared minus 19 times 2? What's that left side equal to? Is it minus 5, yeah? Yeah, so minus 5 is equal to 5c, is it? So in which case, c is equal to negative 1. Yeah, everybody alright with that? Good. Then let x be equal to negative a half, yeah? Ugh. So 8 times by negative a half all squared minus 19 times by negative a half plus the 1 is equal to, now this, it's the first term that she's only not got the 2x plus 1 in. So it's going to be a times by negative a half minus 2 all squared. Because of the 2x plus 1, that's going to be plus 0b plus 0c. So let's work out what that left-hand side is. Pardon? The left is 5. That one's 12. Okay, so this is 12. And then it's 12.5. And then this is equal to 6.2a. That makes sense. So then a is equal to 2, is it? Perfect. Now it's this last one that's the hardest one, isn't it? Okay, because we don't have anything now to substitute in. So you've got to use the other method, which is comparing the coefficients. Now, if this was me, which it is, which one don't I have? I don't have B. I'm just trying to think which is the best coefficient to compare. Potentially the x squared. Yeah, we can do the x squared. Yeah. The reason we do the x squared is because there's only 2 with the x squared, isn't there? So compare x squared. So in which case it's going to be the coefficient on the left hand side of x squared is 8, which is equal to, now it's going to be x squared, isn't it? It's going to be your first term, so it's just going to be a for that one plus for the middle one it's going to be 2x times by x, which is going to be 2x, so plus 2b, and then there's no x squared on that last one, so we don't include it. Okay, everybody happy with that? And then all we need to do is to sub in a to find out what b is. Okay, so this is going to be 8 is equal to 2 plus 2b. So then take away the 2, which is 6, divided by 2, b is equal to 3. Still not finished. We're still not finished, because that's only given us our partial fraction, hasn't it? So we've now got to actually integrate this. So we're trying to find the integral of a, which is 2 over 2x plus 1, plus b, which is 3 over x minus 2, plus c, which is minus 1 over x minus 2 all squared. That's going to be the one that's the tricky one, isn't it? Why is that one the tricky one? Yeah, it doesn't integrate to ln x, that one, does it? We're going to have to bring it up and use the reverse chain rule. So the first one's, that 2 inside it as well. Yeah, be careful of that. So the first one's okay. So if I integrate this one, it's going to be 2 ln of 2x plus 1. If I differentiate inside, I get 2. So I need to divide by that 2. So divided by 2. Everybody happy with that? Plus 3 ln mod of x minus 2. This one on the right hand side is a bit annoying. I'm going to write over here. Just going to highlight this. Highlight this one. Because actually the way I'd probably start this off is to write this one here like x minus 2 all to the power of minus 2. And if I integrate that, I'm going to get x to the minus 1 all over minus 1. And then there's nothing inside to differentiate, so it differentiates to 1 inside. So it's going to be the minus minus, isn't it? So it's going to be plus x minus 2 to the power of minus 1. That's the hard one, isn't it? Plus c. Everybody alright with that and where that's come from? Okay. -2, the power of -2 increases to -1. Okay. I then need to divide by that power, which is going to be minus. Right, so at the moment that's minus x minus 2 to the -1. Because there's already a minus inside there, it's going to cancel it out, so it's going to be plus. Then I would usually differentiate inside that and divide by that. But if I differentiate x plus 2, I end up with just 1. So it's just divided by 1, which means it's the same. Okay. I would then probably simplify this. Just because. Oh, I'd cancel that as well, wouldn't I? So this is equal to ln of 2x plus 1 times by, bring the 3 up, so it's going to be x minus 2 to the power of 3 plus 1 over x minus 2 plus c. Can everybody see where that 3 comes from, that power of 3? Yeah? We alright with that? Yeah? Let's just check the answer. Yeah. Okay. There's a test your understanding here. I think I'm going to skip it. I want to move on. I think we should be alright with that. Are we okay with that? We'll do some of that in our homework. Okay. I want to try and plow on. Okay, this next one. Integrating a top-heavy fraction. Okay, integrating a top-heavy fraction. We did this at the start of year 13. How do we deal with top-heavy fractions? Go on. A plus B over. Yes, yeah. That's exactly it. Yeah. Sorry. So you're gonna have your divides, but how am I doing that? What method am I using? Yeah, the long division method. Yeah. So I'm going to be using long division method for this. Okay. So is this the question? Yeah. Yeah. So yeah, we need to use long division for this. Okay. So if I'm using long division, you've got to be really careful, haven't you? And the reason you've got to be careful is because of those. At the moment, it's just x squared. Okay. However, we know we've got to include 0 values of the ones or of the coefficients that of the values it could be, if that makes sense. So the reason this one's hard is because the starting point is I'm dividing by x plus 1, that's just fine outside. But how many times does that go into x squared plus 0x plus 0 there, like so? Does that make sense? I've got to use those there. Okay. All right, so now we are doing the long division. So how many times is x going to x squared? It goes in x times, and then I multiply by that and subtract. So x times by x is x squared, x times by 1 is plus x, and then I'm subtracting those there like so. So x squared times take away x squared is 0. 0 take away x is equal to minus x. Bring the 0th term down. Everybody all right with that? Yeah. So then I need to do minus x divided by x, which is going to be minus 1. So then minus 1 times by x is minus x. That's the whole point, isn't it? And then minus 1 times by positive 1 is going to be equal to minus 1. There, like so. So then if I'm subtracting that, it's going to be minus x minus minus x, which is nothing. But 0 minus minus 1 is going to be positive 1. Everybody all right with that? Yeah? So, that's pretty much giving me what I want. However, I need to write it in the format that works so I can actually integrate it. So, here now, it's the integral of x squared all over x plus 1 with respect to x is equal to, so if I divide by x plus 1, it's equal to the integral of x minus 1 plus, so that's what I get if I divide it by that, but there's also a remainder, and my remainder is 1. So I've got to write it as a divisor, so it's going to be 1 over the thing I was dividing by, which is going to be x plus 1 with respect to x. Yeah? Everybody alright with that? Can you remember that? Yeah? Cool. The last little part is now that I need to integrate this, don't I? So this is equal to x integrates to x squared over 2 minus 1 integrates to minus x, and 1 over x plus 1 integrates to plus ln of x plus 1 plus c. Everybody alright with that? Yeah? We're using those old techniques and combining it with the things we've done. I think they're alright. Thumbs up, thumbs up, thumbs down? Cool. Look at that. Alright, have a go at that one on the right, let's say. Have a go at that one on the right. Do you want me to start? See if you can catch up. Okay, so the first thing I need to do is actually divide this. So, how many times does x plus 1 go into now? You need to make sure that you write it as x cubed plus 0x squared plus 0x plus the 2 at the end. Okay, so how many times does x go into x cubed? It's going to be x squared. X squared times by x is x cubed. X squared times by 1 is equal to plus x squared. Then I need to subtract. That one's going to be 0. This is going to be equal to minus x squared. Bring the 0x down, like so. X squared divided by x is equal to minus x. and times it. So minus x times by x is equal to minus x squared. Minus x times by 1 is equal to minus x. Subtract them. So that's going to be 0, and that's going to be plus x because minus minus. So that's going to be plus x there. So then x divided by x is plus 1. So then 1 times by that is going to be plus x. Oops. Bring that down, should have. So then 1 times by 1 is plus 1 as well. So if I subtract those, I'm just left with the remainder of 1. Okay. So if I integrate x cubed plus 2 all over x plus 1 with respect to x, this is equal to the integral of x squared minus x plus 1 plus my remainder, which is 1 over x plus 1 with respect to x. Everybody all right with that? Yeah? So now when I integrate this, I end up with x cubed over 3 minus x squared over 2 plus x plus ln of mod x plus 1 plus c. Love it. Everybody happy with that? Don't like the fact that it's on the 2 lines. Alright, everybody alright with that, yeah? Okay, so the next stage is finding areas. So we've actually gone through all of the methods now for integration. Okay, I don't think there's any, as far as I can think, there's no more methods. We've actually, so it's just about applying integration to different skills now. So one of them is finding areas. One of them is differential equations. One is forming equations. So we'll go through those. But everything you need to know now in terms of integration, you know. Okay? It's just about applying it to situations. And the hard part now is what? What's the hard part now? Knowing which method to use, isn't it? Because we've got reverse chain. We've got integration by substitution, which is, to be honest, that's the one I use all the time. You've got by parts, so when they're multiplied together, and you've got inspection. That's, have I said that one? No. Inspection and partial fractions as well. Okay? Inspection's where you're looking at what's outside. So if it was, for example, if there's an x cubed inside your ln, and you've got an x squared outside, but don't forget you can use substitution for that one to replace it. You just replace what's inside. Okay, but you can use inspection for those ones as well, which we did do. Okay. Here we go. Here's a question. Yeah. So, you're already familiar with the idea that a defined integration gives you the area bound between the curve and the x-axis. We know that. So, the diagram shows this one here. R is the bounded the region R is bounded by the curve and the x-axis line shown as 0 and 4. Use integration to find the area of R. So this is from the textbook. It's basically saying this, isn't it? So you've got a curve which is y is equal to 9 over the square root of 4 plus 3x. And it's asking you to find the area between 0 and 4. Okay? So this is what it's looking for. It's looking for the integral between 0 and 4 of 9 over root of 4 plus 3x with respect to x. And now it's just a case of which method do I use. Okay. Now there's a few different methods you can use here. You could use, there's a couple. You could use substitution if you want. You could use the substitution of let u be equal to, or what would you let u be equal to in this one? 4 plus 3x, yeah, you could let u be equal to that. and then change it and make it an easier expression. However, because I can see that there's a square root there, and actually the 9 on top, the powers, when I differentiate inside there, actually, from inspection, we can see that we can actually use what I've got, can't I? So I probably would use inspection, or would I use... Honestly, personally, I always use substitution. I just find it that much easier, to be honest. You can use inspection if you want, in which case you'd have to increase it. I'm just going to use substitution just because I like it and I prefer it. Okay, you can use inspection if you want. I find that substitution kind of gives you some things that you need to do. You could use a calculator as well. Okay, you could use a calculator as well. Yeah, I didn't even think about that. However, we've got to be careful with that. When can we not use the calculator? If it's asking for exact values, okay? And sometimes I'll calculate it around. I'm going to do it anyway. I'm just going to use, just to get used to seeing integration, I think it's important. So I'm going to say, let u be equal to 4 plus 3x. In which case, I then need to differentiate this. So du by dx is equal to 3. So in which case, dx is equal to du over 3. I've got to be really careful. What else do I need to change if I'm using substitution? What else do I need to change? Not x. I don't actually need that in this one. The boundaries, yeah, the limits, okay? So, so let's put bounds over here. Because don't forget, 0 and 4 are x values. And actually, I'm doing everything in terms of u. So I need to do for x equals 0, I need to sub in to my substitution, which is u is equal to 4 plus 3 times by 0. So u is equal to 4 for that one. And then for x being equal to 4, it's going to be u is equal to 4 plus 3 times by 4, which is equal to 12, 16. Yeah? So now I can start replacing all of this. So I'll highlight what I'm going to replace where. So this here is my u, isn't it? That's u. The x here is this part here. And my bounds are 0, which is here. And my other one is 4, which is here. Okay? So just to make it nice and clear with those colours. So 0 between my limits of 4 and 16 of 9 over root u times by du over 3. Okay, I've replaced everything there now. So that's going to cancel to be 3. And then I end up with the integration between 4 and 16 of 3u to the minus 1 over 2 du. Everybody all right with that and where that's come from, yeah? So this is equal to 3 to the power of, well, plus 1, which is going to be a positive half. Divide by that power, which is going to be, dividing by a half is the same as times by the reciprocal of that, so times by 2. So it's going to be times by 2 there, like so. Everybody all right with that and where that's come from? Between my limits, which conveniently are both square numbers, of 16 and 4. So this is equal to, well, let's just write it, 6 root u between 16 and 4. So this is equal to 6 root 16 minus 6 root 4, which is equal to 6 times by 4 is 24, minus 6 times by 2, which is 12. 12 is the answer? 12. Now, as you said, you could have used the reverse, inspection for that. I just like using substitution. I think this is kind of more, you kind of do this process with substitution, isn't there? So it just becomes a little bit easier. But is everybody all right with that one? Yeah, nice and straightforward. Cool. They will have used inspection. I know they will have used inspection. Okay. Oh, sorry, it's not even inspection. It's the reverse chain rule, isn't it? Okay. All right. Okay. So the area between two curves. Okay, the area between two curves. Now, we've already had a look at this at AS level. Okay, we've already had a look at the area between two curves, and it's all about the fact that we are taking away two areas. Looking at this one here at the top, okay, if my f of x is that top function, and by top function I mean higher than the function below it, literally higher, the y values are all higher, then I need to do f of x. So everything f of x is going to be if I find the integral of f of x, it's going to be this area here. So this here, this yellow I've highlighted, I know it looks a bit green on top, but this here is the area of f of x between a and b. Everybody all right with that? If I then want to find the area of R on top, what I need to do is I need to subtract the area of this. Just ruin everything now. Of this pink/red area, which is this part here. So it's going to be the area of the yellow subtract the area of the red. In which case this is going to be, everybody all right with that? Yeah? So it's the area of everything under the top curve subtract the area of everything underneath that bottom curve. Okay? Everybody all right with that? And it gives you this formula here. Now, you can combine integrals, okay, if they're between the same limits. So actually what we can do here is, this is the formula here, and it's the fact that if I want to find the integral between f and g, it's the integral between a and b of f, knowing that g is underneath. It's the integral of between a and b of f minus g. Does that make sense? But that's only if f is on top. F of x, sorry, I should say. Does that make sense to everyone? Everybody all right with that? Okay, thumbs up, thumbs down, thumbs down. Okay, cool. Let's have a look at this one here then. The diagram shows the curves y is equal to sine 2x. And y is equal to sine of cos squared, where we're between 0 and pi over 2. So you could, if you wanted to, do these separately. And actually, if I was to look at this, I would have done these separately. I probably wouldn't use that formula in pink. I prefer to work out the formulas separately. However, in some cases, not all the time, if you combine them, it makes the integration easier. Okay, it doesn't in this case because they're all horrible trig identities. Okay, so for me, for this one, I probably would work them out separately. But you could, if you wanted to, do this. So this is our first one, isn't it? This is our top one there, which is this top one here. This bottom one is this one here. Okay, which is this one here. Now you could write it like this if you wanted to. So this is the integration between 0 and pi over 2 of sine 2x minus sine of x cos squared of x. You could do that if you want. There's no reason why you can't do that. With respect to x. Or you could do them separately and then subtract them at the end. While I've got that, I might as well just leave it like this and do it. So there's two things I need to deal with here. The reason I may have split them up is because you can actually use the substitution of cos x, that one on the right, if you wanted to. Okay, if you substitute cos x in, it becomes easier. However, we're actually going to have, if I'm doing it this way, I need to use inspection. Okay, So if I'm integrating here between 0 and pi over 2, the first thing I'll probably do is write it so that I can use inspection. So sine of 2x minus sine of x cos of x all squared with respect to x. Now, why have I had to write it like that? Yeah, what do we notice about cos x and this minus sine x outside? That's the differential of that, isn't it? Yeah? Cos x inside there is equal to the differential outside there, which is the minus sign. Okay, you thinking about this? So sine, cos, minus sine, minus cos. I know that cos integrates to sine. Yeah? Cos integrates to sine. So what you would need to do for that second one is consider that this part here needs to be the higher power. So you'd say let y be equal to cos of x all cubed. So this is using inspection, isn't it? So then if I differentiate this, dy by dx is equal to cos of x all squared divided by 2, and then I differentiate inside that and I subtract it. So it's going to be the differential of cos is minus sine, isn't it? Yeah, the differential of cos is minus sine of x. So I end up with minus a half sine of x times by cos squared x. Everybody happy with that? Thumbs up, thumbs middle, thumbs down. So what's extra then? There's an extra what? Half. So what do I need to, how do I compensate for that extra half? It's going to be what? It's going to be 2. I need to put an extra 2 at the top so it cancels out. Look, what I'm talking about here is how does this here, how does this compare to this? When I so it should be 2. Sorry, my fault. Yeah, sorry. I'm with you. Sorry. So that there shouldn't be a half. It should be 2. Yes. Yeah. Sorry. You're right. So it's going to be bring the power down times by 3. Sorry. Yeah, you're right. So that's equal to 3. So then that's equal to this times by minus, it's still minus sine of x. So this is equal to minus 3 sine of x times by cos squared of x. Good. So now I'm comparing, this to this. And actually there's an extra 3, sorry. So in which case, because there's an extra 3, I need to have a third on top. So I need to have an extra third here. Yeah? So now I'm integrating this. I'm integrating. So if I integrate sine of 2x, well, sine is going to integrate to minus cos. So it's going to be, don't forget then I need to differentiate and divide by that. So it's going to be minus a half cos of 2x. Let me have some more space. So this is going to be equal to minus a half cos of 2x. If I integrate that, we know it integrates to a third, positive third, cos cubed x between 0 and pi over 2. If you put that in your calculator, does it give you an exact answer? Or does it give you as a decimal? Probably would try it. So then I need to do minus a half cos of 2 times by pi over 2 plus a third cos cubed. So in fact, I'm going to write that instead of like that. I'm going to write it as cos of pi over 2 all cubed. I'm going to write it like that because that's how you're going to have to put it in your calculator. Okay. All of that minus a half cos of 2 times by 0 plus a third cos of 0 all cubed. Everybody happy with that and where that's come from? So what's that equal to if you put that into your calculator? Anyone done it? Should I do it? Two over 9? Everybody else get 2 over 9? Let's check on her. 2 over 3 they've got. That should be a minus there. Did you forget that minus? They've got 2 over 3. 2 over 3, yeah. And it's worth checking both methods, okay? It's worth making sure that both of those work, okay? Even when it's not exact, even when it's asking for an exact answer, maybe in terms of E or in terms of root 2, it's always worth using your calculator to see whether that rounded decimal is the same as the exact value that you've got, if you know what I mean. So it's going to be the same up to 12 decimal places, isn't it? Do you know what I mean by that? Yeah? Everybody alright with that? You sure? Alright, have a go at this one yourself then. Do you want me to zoom in a little? That's almost exactly the same as the first one we did. It's not too difficult. Have a go at that one yourself. Very similar to that first one we did, wasn't it? Did you use substitution? Did you use substitution? I use substitution. I prefer. It's easier to see. Alright, should I put the answers on? Yeah? So for this one here, I'm just going to pop it up there. 3 units. Everybody alright with that? Do you want me to go through it or not? It's very similar to that first one, isn't it? Okay. We will be doing some practice on these. Okay, anyway. Alright, is everybody alright with that, yeah? Okay, let's move on. So, next up, the trapezium rule. We didn't do the trapezium rule at AS, did we? It used to be an AS topic, this. Yeah, actually, it does also come up at GCSE. Yeah, it does, yeah. Yeah, it comes, well. Yeah, so it does also come up at GCSE as well. However, at A level, instead of having to work out the trapeziums individually, there's a formula that we use. Okay, there's a formula that we use. It's in the formula booklet, as you could probably guess. However, the problem we've got is that not all functions or lines can be integrated. Okay, sometimes you can't find an exact value for something. Okay, so you've got to know other methods to find out an approximate value of the area underneath it, in which case the trapezium rule is one of those methods. Okay, and it's all about splitting it up into equal widths and then turning them into trapezium or trapeziad, not sure which one. Alright, so this is the formula, okay? Now, I'll talk you through this. I'll talk you through this and where the formula comes from, okay? So if you have a look here, I'll zoom in so you can see it. Okay, I'll zoom in. So here we have a curve that we can't integrate. Don't worry about writing that down just yet, okay? Because that's not the formula. This is basically proving the formula, okay? So what they've done is they've split each of these up into equal widths of length h. They call that h, okay? Because that's the height of the trapezium. Your A and B of the trapezium is the y values as the curve changes. So this one here, the first one here, is so this one here, first of all, this one here would be A and B, wouldn't it? Okay, because that's the top and bottom of the trapezium. Then it would be A and B here, because that's the top and bottom of the trapezium, and then it's A and B here. So you end up with this formula. You've got 1, 2, 3 trapezium. So it's going to be a half a plus b times by h. So it's a half y0 plus y1 times by h. That's this part here. And then if you're simplifying this, you can actually take out the half and take out the h as a common factor. Okay? The only one that you need is that, so we've taken 0 out, sorry, we've taken a half out as a common factor, we've taken h out as a common factor, and it leaves you with, you've got one of the first row here, because you include y0. You've also only got one of your last row. So let me just, in fact, let me write on here which ones we're using. You'll see what I mean now when I talk about this. So here we've got our h's, like so. So h, h, h. So for this first one, you've got, sorry, for your first trapezium, it's going to be y0 and y1. That's what I'm going to be using. Then for my second trapezium, I'm going to be using y1 and y2. For my third trapezium, I'm going to be using y2 and y3. So if I just not think about those for now, notice how you've only got one y0, one y3, but then you're going to have 2 of everything else, aren't you? Because you're working out these trapezium like so. So actually, this is where it comes from. So you end up with 1 y0, 1 y0. You end up with 1 of the last term, in this case it's y3, and you've got 2 of all of those middle ones. Does that make sense? You can see where that's come from, yeah? So that gives us this formula here. Okay, now this is the one you do need to write down. So the integral of between a and b of y with respect to x is equal to, sorry, is approximately equal to, because remember it's not exact, h over 2 times by y1 plus 2 times y2 plus all the way up to your second to last term, which is y of n minus 1, plus your last term, which is yn. Does that make sense? Get that down. Although it's in your formula booklet, get that down. Everybody all right with that, yeah, so far? Okay, so with this one here, you've got to work out all of your values. And you, first of all, I'll do this example and you'll kind of see how it works. We're integrating between 1 and 3 the curve y is equal to x squared, using 4 strips. So the first thing I would probably do before anything is to work out what your h is. And you do that by doing the upper bound take away the lower bound divided by the amount of strips. Yeah? So in this case, it's going to be 3 minus 1 divided by 4. So my strips are equal to 0.5 in this case. Does that make sense? Then with this one, so my first value is going to be 1. My second value is then going to be up by 0.5, so 1.5. Then it's going to be 2. Then it's going to be 2.5. And then it's going to be 3. Now you might think to yourself, well, I've got 5 numbers there, but it only wants 4 strips. Now remember, the strips are in between these. Okay? So actually you've got 1, 2, 3, 4 strips. Does that make sense? Everybody all right with that? So let's just tidy this up a bit. So then we've got to work out our y values. And how do I work out my y values using y is equal to x squared? I'm literally just going to square each of them. So it's going to be 1. What's 1.5 squared? What is it? 2.25. 2 squared is 4. 6.25 is it? 6.25 and then 9. Okay, so then now I've got my h. I've got my first y value, which is 1. I've got my last y value, which is 9. So it's going to be, my area is approximately 0.5 over 2 times by my first one, which is 1, plus 2 times all of the ones in between there. So that's going to be 2.25 plus 4 plus 6.25 plus my last term, which is 9. So then if you sub that in to your calculator, what do you get? Anyone? 8.75. What am I? This is going to be units squared, isn't it? It's the area of this, isn't it? Everybody alright with that? Everybody alright with that? Yeah? Alright, alright, have a go at that one yourself. Have a go at that one yourself there. Have a little go at that one yourself. Now they've told you here that if you wanted to, you can actually generate them using the FX button, and you can do that on your calculator. So if you click on Mode, Table, use the alpha button with the X functions, you can actually just press equals and then type in f of x, and it gives you all the values of this in a table. So if you go to three, yeah, mode is, so menu, where is it? Menu what? Menu 9, yeah? It's because they're using the old calculator, so ours is menu 9. So then f of x is equal to that function there, which is alpha x over the square root of 1 plus alpha x. And then we want it to start with 1, end with 0.5. And how many steps do we want? 1, 2, 3, 4, 5, 6. Yeah? Oh, sorry, your step is not 6, sorry. Your step is your h, isn't it? So h in this case is equal to 0.1. Sorry. There we go. Everybody alright with how to do that? Yeah? Everybody know now? Do you want me to see if I can do it on my calculator on here to show you? It's not the same though, that's the problem. It's not how many strips there are, it's the steps. So it's going to be, in this case, equal to 0.1. The step, yeah? I can do it on this. Alright, so on this one, if you click on, this is the old calculator, isn't it? That's why. It was mode and then 3. So it gives you this. Okay, on yours it's menu 9. So if I type in here, alpha x over the square root of 1 plus x equals start at 1, end at 1.5. Oh, is that? There we go. Yeah, everybody all right with that? All right, finish that question off then for me. Finish that question off. Everybody all right with that, yeah? Do you want me to start doing it? What was 1.3? Oh, 0.85771. Okay, so it's equal to a half of 0.1 times by 0.7071 plus 2 times by 0.7591 plus 0.8090 plus 0.8571 plus 0.9037 plus 0.9487, and that's equal to this part down here. Okay, 0.416. Now that is 4 marks, which if it comes up in this is an absolute gift, isn't it? Okay,